Hello, everybody. Good afternoon, good morning, good evening, depending where you are. Welcome to our presentation, Static Code Analysis and Dynamic Tests, two complementary procedures for quality assurance. This presentation will last about, I think, 45 minutes, and after, at the end, there is a chat. You can write your questions, but we can also, at the end, we can talk together. Maybe it's even better than writing. I'm a bit old school there, so. Okay, good. My name is Klaus Lambert. I'm co-founder and CEO of the company VerifySoft. In this talk, I will present you some basics about static code analysis and dynamic test, including code coverage. Code coverage is part of dynamic test. This is all is very important. And then I will go into advantages of both methods of dynamic test and static code analysis, but also show you the limitations of each method. I can already tell you, you need both, and you need tools for doing this properly. And for these reasons, at the end of this presentation, I will give you some selection criteria for choosing a tool. You may know we are providers of software testing tools, but my recommendation will not be by our tool and then all is good. I will give you independent criteria so that you can choose during an evaluation what is the best tool for you and your needs. So some words about our company. VerifySoft has been founded in 2003, so 21 years ago now. We are based in Offenburg. You may not know this. It's a little town in the southwestern part of Germany, close to the French border. So here, and we are about 20 people here in Offenburg, and worldwide we work together with distributors which present us in important markets all over the world. And yeah, what we have as tool, we are developers and distributors of software testing tools. We have our own tools. The most important is TestWell CTC++. This is a code coverage analyzer. CTC stands for C and C++ test coverage, so it's a code coverage tool. Then we have two matrix tools. Then complementary to our tools, we have tools of partners. So complementary tools, one of them is the company CodeSecure in US. They provide a static code analysis tool named CodeSonar, and this is mainly for detecting bugs and programming and checking for programming rules and coding standards. Then CodeSonar has also a tool named CodeSentry. CodeSentry is more for security reasons. This is a tool which checks third-party software. You don't have the source code, and they check what in the open source and what in the third-party code, what components are in the code, and the tool makes a software bill of materials, SBOM, and with this you can see if there are security vulnerabilities in your software. Then for people which have code they don't understand really well, this should happen if you had old code, legacy code, and you don't find yourself in this code. There we have a good tool, Imagix 4D, this one. And brand new on the market is Cody, a Spanish tool. Cody is a static code analysis tool for increase the performance of your tools. So it's about the speed of your software. You can find here bottlenecks, and also most of them you can correct. Then we provide also seminars around the tools, but also around testing and quality in general. So Fortunately, also we have a couple of customers, currently about 750 in 43 countries, mostly from safety critical sectors like automotive, aerospace, healthcare. And yeah, this should be enough for now concerning our company. If you have questions concerning the tools and us, we are available later, and you can contact us also at any time. So to the topic now, so static analysis and dynamic analysis, or better dynamic testing. Static analysis here means that you have a look to the code. You access the source code. So for this, there is no need to execute the code. So with static code analysis, there is no need to write test cases. So such static code analysis, such checks can also be done manually as a part of a walkthrough or inspection. But however, the quality of these manual actions depends always on the employees and their wakefulness at the time of inspection. It's also difficult to tell authority like TÜV. My colleague John Doe has had a look to the code, and normally he finds all errors. This doesn't work very well normally. This means, in addition to the manual checks, which you should do, but you should use tools to do the static code analysis. So such tools are consistent, have a consistent quality, and never get tired. Yeah? And with good tool, you also get cross-modal analysis and analysis of millions of lines of code. And this is something where your colleague John Doe definitively what he cannot provide you. Loosely speaking, static analysis is about checking for errors and compliance with programming guidelines. And hooray, as I told already, there is no need to write test cases for this static code analysis. On the other side, here we have the dynamic analysis, which dynamic analysis you check during the runtime, during execution of the code, if the application works as is expected. Does it work according to the requirements? Does the software what it should do? So this is a different approach. You see already you need both static analysis and dynamic analysis. The static analysis, which checks if the software in itself is okay, and the dynamic test, which checks if the software does what it should do. So now let's have a look to the cost of a software error during the development process. This is a picture from the book of Barry Boehm. This was an American mathematician. The figures are not that important here. Important is that the cost increases during exponential during your project. When you see during the definition phase that something is going in the wrong direction, it's quite easy to correct that. Yeah, someone might see that and say, oh no, this is wrong, we should do it like that. Very easy. If you find an error at the development test, so you have to correct your software. This is some work, and it's already a bit more expensive. If you find it earlier here during the implementation, maybe the developer himself sees, okay, there is an error, and correct this on his desktop immediately, it's less expensive then. And the worst case is when the error occurs after delivery to the customer. When, for example, a car manufacturer has to recall all cars, or for aviation provider, all the planes the aircraft cannot fly. This is very, very expensive. So what does it mean? The earlier I test, the earlier I find the error, the better it is. So start of dynamic analysis, I can only do this when the implementation is done, when I have something, a software which I can run, which I can execute. Compared to this, the static analysis is easier. It's already here during the implementation. So as soon as you have a little part of code, you can already check it by a static analysis. That can be done by the developer itself. That means when you have a static code analysis tool, every developer normally should have access to this to check already his code before checking it in. This is a good procedure, and then of course at the end and during the development phase, then also you should always check statically. But already the developer can do this. And you should see here compared dynamic and static. Static is earlier. This is shift left. Yeah, you go left with this start of analysis. So now, before talking about the checkers which are provided by static code analysis tools, I want to show you this slide here. Today, normally, you don't develop all your code by yourself. You will use normally open source software. You use external software which you buy, commercial software. And for this part, for your own development, you have the source code. But for this part, you don't have the source code, you have only the binary code. But there is good news. A good static code analysis tool, they can analyze both the source code as well as the binary code. Yeah. The check of the binary code may be not at the same exact level as the source code checks, but you already can find here a lot of problems and a lot of issues. So now to the checks which are provided by static code analysis tools. We have first the syntax. This is something which is also done by the compiler, but not at the same quality and not at the same depth. We had this morning, we had this presentation in German, and someone asked us concerning Visual Studio, the static analysis of Visual Studio. Yes, it's also done, but also there it's not the same depth and not the same quality as a professional static analysis tool. Then a static analysis tool also checks for semantics. That means such things as, when I tell it in a sentence, it's colder outside than at night. This sentence doesn't make any sense, but the syntax of this sentence is okay, but it doesn't make any sense. And static code analysis tools today also can find this kind of errors. Of course, to a limited extent, because the tool must somehow understand what it's meant in the software, but good static analysis tools can also do such checks. Then we have control flow problems like unreachable code, like jumps into or out of loops, data flow anomalies such as uninitialized variables, for example. Then concurrency problems when several threads are executed in parallel, such as race conditions, for example, data races. If synchronization was forgotten or done in an incorrect manner, deadlocks, all these kind of things, and this concurrency analysis. This is a key discipline of the static code analysis. The static code analysis is very, very strong here, and these problems, these concurrency problems, normally cannot be found by dynamic analysis. It cannot be found or not be found easily when you execute the code. This until here, this is about finding real bugs in your software. Now it's more about programming rules. So we have also checks for programming rules and coding standards like MISRA or AUTOSAR, for example, or there are still metrics like HIS matrix. By the way, the programming rules are requested by a lot of standards. And most tool offers also the possibility to implement own rules in a quite easy way. Then we have, maintainability and matrix like Halstead and McCabe, and his matrix is here, his matrix. There are also a lot of other metrics, even metrics like estimated number of bugs or time to understand the code. Such kind of things also can be checked. I know these metrics are sometimes criticized. It is not always when your software is quite complex that your code is wrong, but normally there is a correlation between the complexity of a code and the error proneness of a code. When you have a very complex code, normally it will contain more errors than a code which is written in an easier way, and it is also more difficult to maintain, and it is, by the way, also more difficult to test a complex code. So this is something which you should also have a look to the matrix and the maintainability of a software. Then architecture analysis. How is the structure of my software? This is important when you will do re-engineering of your software, or when you want to understand a software which is old, which you don't know no more, which has been developed by people which are no more in the company. This can help here. And due to the connectivity of also today of the embedded systems, because the embedded systems are no more alone somewhere in a device. The device today, it is connected to the internet very often. It's connected to other things, so it can be hacked from outside. And for this, security checks are very, very important today as well. And static code analysis tools provide also this kind of checks. So let's have a brief look to the standards. What is requested by the standard? I have taken here the ISO 26262. This is the automotive standard. Most of our customers are from automotive, but in other standards it's quite similar. And you see here already control flow analysis and data flow analysis are highly recommended already from the level ASIL-C. D is the highest level, R is a low level, this is the highest safety level. So this is already requested from ASIL-C. Static code analysis is highly recommended already for the level B, and it is recommended for ASIL-R. That means you have to do it. Yeah. So here are some examples for checkers. This is only a partial list. First, for safety, good tools will provide you more than 100 checks here. I'll let you have a look to this. We'll have a cup of tea, not a cup, drink a tea. So these are the checkers for safety. Some examples, and for security also a couple of checks here. You see buffer overrun and so on, and important here many more depending on the tool. And this is something you should evaluate during, you should check during evaluation what the tool is providing before purchasing a tool. So now once more look to the slide we have seen before. For the static code analysis we have seen, it can be performed early in the development process when the fixing of errors is still not that expensive. We have a lot of different checkers, and the analysis is done automatically without the need to write any test cases. So usually without any effort from your side, you have only to install the tool and to run it. That's it. Okay, when it finds issues, then you have to fix them. That is clear. So complementary to this, at runtime, we have the dynamic analysis. And what's going on during the dynamic analysis, I will show you. The dynamic analysis checks if the application works as requested. For this, you feed the application with test cases. You get then the test results and you compare your test results to the expected test results. Yeah, does the tool what it should do? If yes, it's okay. If not, yeah, you need to change something. All this happens at runtime. And during this test at runtime, for example, unit test or integration test, you should measure the code coverage. Why? Because you should you should test 100, normally 100% of your code. If you have parts which are not tested, it may be that there are great issues in this code which might occur later. So what is code coverage about? Code coverage shows you the completeness of your test. It doesn't show you the quality of your test. So you should still think about which tests you will do, and to do only tests to get the coverage to 100%. This alone is not enough. This is not good. You should think about what are good tests. And in this context, you should, for example, boundary tests should be done, and the test also should be based on your requirements. Yeah. So what does it mean, completeness of tests? Yeah, it depends. It depends. So we can start, for example, here that we ask ourselves, is every statement has been tested? If we have tested every statement, this would be statement coverage. This is a quite weak coverage level. We have even weaker would be function coverage. In the other direction, it's becoming stronger, more severe decision coverage. The path coverage is rather theoretical, because when you have a loop here, and yeah, you have a lot of possibilities, and you might test until the end of your life. So this is also not requested by the standards, but here the condition coverage is requested by standards. For example, condition coverage here, and the highest level here is the multi-condition coverage. Here, with multi-condition coverage is checked if every possible combinations of all atomic conditions, so of every part, have been evaluated as true and as false. And when you have a software with a lot of atomic conditions, this will lead to a lot of test cases. For this reason, there is a simplification which has the same results, but with less test cases. This is MCDC coverage, or modified condition decision coverage, and this is the highest level which is checked, which is requested by the standards. This brings us to the standards. So here you see from the function coverage to the multi-condition, or something is missing here. Multi-condition coverage, the levels of coverage, and you see, for example, the 26262, the standard for the automotive sector. It requested for the ASIL-D, which is the highest level, modified condition decision coverage. Yeah, this is highly recommended. Highly recommended means you have to do it. And for the other standards, for example, the DO178C in aeronautics, the railway standard, and the general standard 61508, it's about the same. Yeah? The levels have different numbers, but at the highest level, you have always to perform the MC-DC coverage. It's a little bit different for the healthcare sector, for the ISC 62304. There you have to test according to the state of the art. Yeah, but this is not explicit mentioned what you have to do, just to test in accordance with the state of the art. But state of the art for me is this here. And then, in my opinion, you also should provide here for a high safety level the MC-DC coverage. So, summary. The focus of static code analysis is detection of errors that lead to undefined behavior. A particular strength of static code analysis tool is concurrency problems, which I have told you cannot be found with dynamic analysis. And yeah, when we talk about static analysis, we are primarily talking about non-deterministic errors. That means errors which can occur later, but which maybe not occur, but it can happen at any time. So sometimes after years, sometimes never, but which could happen at any time. I have a little story here. We have been yeah, we have a lot of contacts with our customer, of course, and some years ago we have been at a provider of, at a manufacturer of computer tomographs, and they had a software, they had a computer CT, computer tomograph, which was in the field already for a couple of years, and it worked all the time properly. But after some years, they have checked the software and they have found really important errors, some bombs in their software, which fortunately haven't occurred in the field and during production later. But yeah, this couldn't have happened, yeah. And in this case, I'm sure the company would have been in a newspaper the day after. So you should check your software with static code analysis and not after 10 years during the development and before delivery. Okay, this is some years ago, and the customer have fixed since that the software. So also the static code analysis reveals serious errors in the source code. It cannot provide information about the correct functionality of the software. This we have seen, and this is done by the dynamic test, by the test during the runtime, by unit test, by integration test, to find the functional errors, to see if the software does what it should do. So conclusion on this, the static code analysis and the dynamic tests are complementary. It's not either or, it's both. You need to do both. So to use, you need to use both methods in order to develop good software. Yeah? You need both. So now this could be a good conclusion of the presentation already, but I have promised you some selection criteria for tools at the beginning of this presentation. First, like in the development process, I want to start with the static code analysis. So we have seen that the use of static code analysis has great advantages: deployment early in the development process, checking programming guidelines, and detecting errors without writing test cases. There is, however, one thing that makes uncovering errors a little difficult with the static code analysis. Let's have a look to this slide. So there are different kinds of errors. So you have two positives. That means the tool gives you detected an error, and this is a real bug. So this is a true positive. All right here, all okay, all good. Then the tool doesn't provide you an error message, but there's also no bug. So this is also good. Therefore, the green here. no false alarm, very, very good. Then sometimes which can happen that the tool misses an error. So there is a bug in your software, but it's not detected by your tool. This is a false negative. And then you have errors which are mentioned by the tool, reported by the tool, but it's not a bug. These are false positives. The tool tells you there is a bug, but when you check it, there is not a bug. This can happen with static code analysis tools because they don't know exactly how your software will behave during production later. So what is important here is that you check your static code analysis tools with example program, for example, if they find your real bugs, and if they don't miss any bug which is there, but also that the tool provides not too much false positives. Yeah, when you have the tool which provides you many false positive, you have and to check them afterwards, and you have checked 10 false positives. The 11th, you will even no more have a look. You will see, oh, this is also a false positive. Forget about it. So this is not good. Yeah, you should have a tool which works here about properly. There's not 100%, no tool which does it 100%, but you can get close to it. So the true positives, the real bugs, of course, you will fix them, but also the false positives, you will check what it is because you don't know before that it is a false positive. So now further selection criteria is the scope and the quality of the analysis. What checks does the tool perform? The checks we have seen before. Which checks they perform? Does it control flow analysis? Does it data flow analysis? And both with which quality? How strong is the tool in detecting concurrency problems? Does the tool work interprocedurally, for the whole software, and in which quality? How are library functions treated in the analysis? Can certain checks be deactivated, or have I always 100 messages for checks which I'm not interested in now at the start maybe? And is it possible to exclude part of the project during the analysis? Or here also have messages for everything? This is important when you check for a tool. So programming rules and metrics, which programming rules and which metrics are checked. How is the coverage of the programming standards? For example, now MISRA C or MISRA C++ 2023, it's rather new. Does the tool check already for this? Yeah. Is it possible to implement own rules? And when you can do it, is it complicated or is it easy to do so? Can you switch off rules? And very important, what is about analysis results? How are your reports? Are they clear? Yeah, can you understand them easily? So is it understandable? Can the results be classified? Yeah. For example, this is an important error. I will fix this at first, and this I will fix when I have a bit more time. And this warning I don't care about. And is there a possibility to classify all this? So is there help when you qualifying the results? So for example, here the tool tells you what is the problem here, but also explains a bit what's going on and why the tool has found this. And the errors, can it be assigned to individual team members? Not because you have done the error, you are the bad guy. It's about who should fix this error. And are there rules for accessing the results? Huh? who can see the results. Further selection criteria is the performance of the tool and the necessary hardware. It's about the scalability. Can you also check large code bases, for example, several million lines of code, within a reasonable time frame? Yeah. I remember 15 years ago, there was static code analysis tool. You run them, and then when you click start, you could go 2 weeks into holiday, and the analysis was finished when you came back, or even not. So that that happened with some tools some years ago. To help to get it faster, the question is, can the analysis be distributed to several computers to work in parallel here? Is an incremental analysis possible, or have I always to rerun the whole stuff to make the whole software checked? And which hardware is required? How many memory I need? So configuration and administration. Is it possible to connect the tool to a bug tracking tool? How does the tool work with your versioning system? Does the tool run on-site or somewhere in the cloud? Not everybody want to load his code somewhere outside the company in the cloud. Or is the tool, do you have the tool in your site, at your facilities? How easy is it to configure the tool? Ideally, there is one guy who does it centralized for everybody. And now a few specific criteria. This was about the static code analysis. Now a few specific criteria for the code coverage tool. This slide we have already seen for several levels. For the high levels, you need a high coverage level. For example, here MCDC coverage. It is an evidence when you have to check for this that you need a coverage tool which provides you MCDC coverage. This is clear. Yeah? And if you don't develop in the highest level now, maybe I hear this sometimes. We are only working in a low level here, ASLA. We need static statement coverage and not MCDC. But maybe in 2-3 years, you are here, you have an ASLD project, and then you have to spend money for a tool twice, once for a cheap tool and once for a good tool. Then you have spent money twice. So it's better to purchase a good tool at the beginning already. So of course it's important that the tool works with your compiler. Better when it works with several compilers or with all compilers. Our coverage tool, the test-well CTC++, it works with all compilers, and this with one license only. And it is also important that the coverage tool has a low instrumentation overhead. We'll tell you in the next slide what it is about. Because normally you will check when you are working with embedded software, you should check on the target. Yeah, and you should measure the code coverage on your embedded target. If you can do this, the standards request that you do it. Not everybody knows that, but the standards request that, and with good coverage tool like test-well CTC++, you can check the target. So about the instrumentation overhead here, we'll explain you. Normally it works like this. You have your code, you compile it, you get the program, and you make your test here, you get your test results. And for the code coverage measurement, the coverage tool adds here in your code, or better in a copy of your code, it adds counters to measure if a test passed in this part of code. This is named instrumentation, and the instrumentation it increases a bit the size of your code. So for example, this here, if R it's less than 10, it will give, for example, this one, so that the tool can count. And it's important that this instrumentation overhead is quite low, and there you should check. There are this overhead from tool to tool. It can be very, very different. So with our tool, with testbed CTC, the overhead is quite low, and if you have still problems to get all this on the memory of your target, there's a possibility with our tool that you made a bit coverage. Here normally is counted how many times you have tested a part of the code, and then it's only counted if you have tested yes or no. This is enough for the requirements of the standards, and then you have much less memory space which is necessary. So then you get the report out of it, the report in different formats, and the report also, it's very important what the report looks like. Do I understand easily what is meant into the report? Here we have an overview about the coverage levels, the percentage. We have here the functions, and for each function I see this is fully tested. Here something is missing, and when I click here on the function, I get into the source code. Yeah. Can I understand this detailed information well? Here is the green code. Here the green parts are tested. The red parts are not yet tested. Then there is, with our tool, there is a new feature which we call justification. Sometimes you have parts of your code which you cannot access by tests because you have done defensive programming. Then you cannot access this, but you can then write here in the code or in a separate a file that you cannot access this, and then this is added in a different color. Of course, this is added to your coverage measure here, and then you get more higher than before with your code coverage, and you can explain why you couldn't reach that. So also important when you are working for safety critical stuff in safety critical project that you can use the tool. So does the tool have a certificate? Here, for example, a certificate of TÜV, and this TÜV certificate confirms that the tool can be used without any further qualification measures in these different standards here, in the 61508, in the automotive standard, and so on. So for this, the certificate is enough. It is a bit different for aerospace project, for project in DO 170C. There you have, in addition to, you have to qualify the tool, you have to show if the tool works properly in your environment. And for this, the tool provider should have a qualification kit or help you with test cases and with advice so that you can then do the proof that the tool is working properly in your environment. So this stuff is of course also interesting for the static code analysis tool, and this brings us to the criteria which apply to both static and dynamic analysis, or static analysis and dynamic tests. So this is an evidence here that the tool have to support your programming language or the language in your project. Then how fast is the implementation for the support of new language standards? When there are new features in the programming language, is this supported? Integration in the IDEs. Is it possible to use the tool via command line? This is important if you want to use the tool in continuous integration processes. Is the tool easy to use? Is it user-friendly? And also important is the cost and the licensing of the tool. When I speak about the cost of the tool, it's not just the tool price. It's also the cost of installing and familiarization with the tool. It's the cost of handling of the tool. When the results are presented in a bad manner, you will spend a lot of time to understand them. All this is time. Time is money. So you should check this. A cheap tool is not always it's sometimes not cheap because you have a lot of work with tests. So cost of the tool, are there annual licenses or permanent license or both, according what you need? And what is the scope of use? Only on your computer or in your project or for your whole location or worldwide over your whole company when you have different sites in US, in Europe, in India, in Australia, for example, then our tools, you can use them worldwide. And the quality of the support. So what are the contact options? Can I only send a mail or can I take the phone and call them? Can I request a web presentation? Or are the people also when I have and I want to know more, are they coming on site to see you? Yeah. Will you get help or only a ticket number? Yeah. Also the ticket and 3 weeks after you get an answer. I think this is not very good. Are there also support for older versions? Because you might not change the version of the tool during the project. And what does the manual or the online help looks like? So market penetration of the tool, also important. Are you the first to use this tool or are there also a lot of references? Are there user testimonials? Have a look on the website of the provider, what other people, other customers are telling about the tool. And are there free evaluations available? And here you can already get an impression of the quality of the support. Yeah? You can see if it fits with the people at the tool provider. So summary, I come to the end of my presentation. Static analysis and dynamic testing are complementary. They are both necessary, not static or dynamic, you need both. For both methods, there are very good tools on the market. Not only our tools, there are also others. So you should check and evaluate them carefully for requirements before purchasing or before choosing one tool. So that is my presentation. I thank you very much for your time and hope I could tell you something interesting for you. Are there questions? Jessica, any questions?
Can you show the first slide of your presentation for the different tools that you use from VerifySoft for the static analysis and for the dynamic analysis?
This one?
I think so. So I think a test well, does that cover all those tests like a static and dynamic tests?
No. To be honest, there is no tool on the market which does all this. So there are some providers, they will tell you, yeah, we do everything, but they do not everything in a good quality. Sometimes then it's like a Swiss Army knife. You can cut something with it and you can screw something in the wall, but it's not really good for everything. So this test well CTC, this is a code coverage tool. This does the code coverage, and the static analysis is done by this tool. So we have a different tool. We have not one tool which does all, but we want to provide you the best for everything. So when you want to have one tool for all, we do not provide this.
So what is the dynamic testing tool that you have?
Yeah, this is a very good question. For dynamic testing, for unit testing, we have not a tool. You can use a free tool, C-Unit, CPP Unit, or other tools like Tessie, like Cantata, or something, whatever you want. And this tool adds to it the testbed CTC, CTC++, does then the code coverage measures for this test. Or you can also do your test by a script and run the script, and that's the CTC does it. We don't have in our company a unit testing tool. This you need to find from other company or a free tool. But we can do the good coverage measure for anything which is on the market.
I see. Thank you so much.
Yeah. I would tell you we have a unit testing tool, but we don't have. It's something. It's the rare things. One of the rare things we don't have. We don't have everything. Sorry about that. Other questions? Yeah. So yeah, once more, thank you very much, and it would be a pleasure if we can meet anywhere or at any time, somewhere later. And thank you very much, and have a nice day. Thank you very much. Bye bye.
Yep. Bye bye.
Thank you for your participation. Bye.
Yeah.